What's up guys, I'm Matt Gary, and on this third episode of the Separation of Concerns and Apex Common Library tutorial series, I'm going to go over the factory method pattern and how it fits in to both of those things. Alright guys, so welcome to episode 3 of the Separation of Concerns tutorial series that I am putting together for the Salesforce ecosystem. So that hopefully using separation of concerns, the separation of concerns design principle in your org, as well as potentially leveraging the Apex Common Library in your org, is a lot less confusing and easier to do. Hopefully. Today we're going to go over the factory pattern, or the factory method pattern, and why you might use it, how it fits into this topic of separation of concerns, and how it fits into the Apex Common Library. So, alright, so the first thing that I always do in these videos, as I'm sure you're aware by now, is explain why you would care to learn the factory method pattern. What are the benefits of it? The biggest benefit of the factory method pattern is that you do not have to declare a concrete class type, in your code. So what do I mean by that? Like, normally, if I wanted to initialize a class, I would do something like this. Task class equals new task service, task service impl, right? That's the name of this class over here that we're going to go over in a little bit. But anyway, so we've got, normally you'd have to initialize a class like this, right? But what if there was a way to do this dynamically at runtime? As in, you don't really know what this class is, but you want to initialize it depending on your situation at runtime, right? The situation might be that the user is of a specific type, or the object is of a specific type, or whatever else, right? I think one of the most common examples that everybody gives for the factory method pattern is, say you're building a video game and you have some animals that spawn in your video game, right? And you want them to just kind of spawn randomly, okay? You don't want the same animal to just spawn all the time, or to spawn in the same place, or blah, blah, whatever. So you create an animal type class, and then you have maybe your dog and your cat class implement that animal class, and or rather animal interface, could be a virtual class, one of the two, doesn't particularly matter. But then at that point, your code can randomly choose, okay, I want to spawn a cat or a dog at this moment in time, given these situations. That really doesn't apply to Salesforce. So the one that I always like to use, because I think it's most common. It's the most common implementation thing I can think of anyway. Almost every single org uses the task object, right? And the task object can relate to any object in your org. Can relate to an account, a contact, a case, some custom object you've built. It doesn't particularly matter. And oftentimes you'll have tasks automatically created for users. A case is created, so then the task is automatically made to contact the customer that made the case, or whatever, right? So maybe we want to build a task creation service that at runtime chooses the right task creation method based on an object that you pass it, and then runs that method and generates tasks for that specific object, right? And we're going to go over how to theoretically build that in just a minute. But basically, it allows you to build, the factory method pattern allows you to build more abstract classes, right? That can kind of adapt to change really easily. All right, so now that we've gone over that, let's just go over a quick example of, leveraging the factory method pattern in a Salesforce type scenario, right? How would we leverage, or how would we leverage the factory method pattern in Salesforce? Like, it makes a lot of sense in video games and things where you randomly spawn stuff or whatever else, but how do you change gears from that all too common example to one that is more Salesforce focused and just, I guess business oriented instead of random generator game stuff? All right, so like I said before, the example I always go with is tasks, right? Tasks often have to be created in different ways for different objects in your system. You could have 50 different objects that create tasks automatically. I don't know, maybe not, but yeah, at least 5 or 6, right? And maybe you want to put a create task button on your object somewhere, on your object page layouts. And you want that task button to be abstract, right? Abstract in a way that you can just drop it on that page layout, and if somebody clicks that button, it's going to create a task in the right way for the specific object type that you're currently on. So in my Salesforce instance, on the contacts object and the case object, I have placed this generic create tasks component. We can see it on the case record 2. There's this generic create task component. And if we take a look at the page and click on this, you can see it's a Lightning Web component I built called the abstract task creator. Now, for each of these object types, I would like different things to happen, right? For a contact where I create a case, I want it, to create it with different parameters and stuff than when I create tasks automatically on the case object, right? So I really have 2 options here. I can use the factory method pattern, or I could create basically a big if-else statement that goes on and on and on, and I have to update every single time that I add this create task to, a new object type, maybe accounts, maybe leads, maybe opportunities in the future. I don't really know. Who knows what my code will be required to do in the future, right? So let's just take a look at the easy route, right? If I didn't use the factory method pattern, so we'll say abstract task creator. Actually, we can just say task service no factory, right? And basically what would end up happening is you'd have a method that was your, task creator. I gotta put the right things in here though. For simplicity, we'll make it void. So we've got our task creator method that we're gonna build here, and we're gonna have it send in a schema.sr, right? Yeah, okay, I'm not crazy. Object type. Cool. And then basically what we would end up doing is we'd say, theoretically we'd have a bunch of domain classes or something that we could call for each object. And so we'd say something like if object type equals case dot SObject type, then call the case domain class dot create tasks method, right? Now obviously the case domain class doesn't actually exist for me. I guess I do have one. It's called cases. I could just randomly initialize this one and call the create task method, right? So I could just call this cases.createTasks and pass it the parameters that it wanted. Cases is a domain class. We'll go over domain classes in a few episodes and exactly what they are, but more or less a domain class is like a trigger handler that also handles object behavior. Domain classes are on an object by object basis, right? So anyway, again, back to this example of a task service without a factory. So for every single one of these types that you might put it on, you'd keep saying something like else if contact SObject type, then you'd call the contact domain class to create tasks, etc., right? So if we had we had an account SObject type, then we'd call the accounts domain class and create tasks over and over and over and over, right? Every single time you wanted to put this on another object, you'd have to set up something like this, and it'd span who knows how many lines. If you ended up putting it on 50 objects, you'd do this 50 different times and your code would become enormous. But what if we had a way to just say, okay, right now we are working with a case SObject type, and let's just dynamically create at runtime the right domain class, right? And do that in a single line. Figure out, okay, at runtime we are dealing with a contact object type, and we'll dynamically create a domain class that represents, the contact, right? So that's kind of what this example here is. So basically I've created a task service that is leveraging the factory pattern to reduce my code. And if I removed all of the comments in here, which I'll just do real quick and then I'll reverse it. If I removed all the comments in here, you can see that, and if we did just the exact same amount of stuff, let's remove all the other junk. So let's see here. Oh, I still need one of these. That guy. Okay, so if I removed everything else from here, just pretend I don't need a unit of work and I'm creating tasks like the other one, you can see this is a very small class, right? When compared to this one. This one could span forever. This one that leverages the factory method pattern, it won't ever grow. This is it. Yeah, you're gonna build this one time. It's gonna figure out what new instance of a domain class I want to create, and then it's going to call the create task method on that, and that's it. I mean, you're never going to have to change this ever again. It's pretty flexible and you know, ready, I guess, for any future permutations that you could potentially make. So let's just take a look at this and figure out how this actually works, right? How does this line right here specifically is the thing that kind of does the majority of the work. But let's figure out what this is and how this works. So the first thing we need to do is take a look at this application class and the domain variable within it, right? So we're going to go over this a lot more in the next video, but this application class is something that you create when you're doing, or when you're using the Apex Common library. And basically it allows you to create these different factories for your different layers so that you can dynamically create them at runtime based on, you know, an object type or something along those lines, right? So in this application class, we have this domain variable that is of type application domain factory. And here we pass it the application selector, this thing right here, but this is less important. We won't really go over this so much now. What's more important is right here. We also pass it this map of SObject type to type. And basically what this allows us to do is say, all right, if we are working with a case object right now, we can pass it the case domains constructor class, which I also know is a little difficult to follow just yet, but the case domain constructor class is right here. It's an inner class that kind of helps with constructing these new instances. But more or less, let's just keep it simple. If I pass into this fflib application domain factory the case SObject type, I'm going to get back a new instance of cases. This guy, this class right here. More or less, that's what this is saying. We don't need to go into any of the details. Just know that if I'm calling this variable and I pass it in the new instance method that is part of this application domain factory. So if we come back over here to the fflib application class and the domain factory inner class in here, there are these methods that are called new instance, where you can send it a set of record IDs or a list of records or some other variations of parameters to construct a new instance of your domain class. So basically what we're saying here is, hey, I want a new instance based on my set of record IDs, and then what this is going to go out and do, more or less, is it's going to go out and figure out, hey, these record IDs are of type case that I passed in, and I need to create a new instance of that cases class. That's basically what it's going to do. More or less, you're going to pass it some record IDs. Those record IDs are going to be of type case or whatever. And then it's going to go find the correct class to initialize based on, you know, the object type that you passed in, or the object type of the records that you passed in. Okay? I know that's a little confusing. The more you go through this video tutorial series, I promise it will become less and less confusing. But it takes time to kind of grasp this concept. So, basically, again, what I'm doing is saying, I want a new instance of my case class to be returned to me based on the record IDs. Oh, actually, sorry. I want a new instance of a domain class to be returned to me based on the record IDs that I pass in here. Okay, those record IDs could be of any object type. I have no idea. It could be of 30, we could put this create task button on 30 different objects. And as long as we continually update this map to say, if we added a new count.SObject type, if we added a new domain class for accounts, then we could also pass in the account object type to be dynamically generated here with this call, right? So anyway, basically, again, we're asking for a domain that is determined by the record IDs at runtime. And you might be wondering what this fflib ISObject domain class is. If you're using Apex Common, all of your domain classes, you're basically trigger handlers with object behavior associated as well. They should extend this fflib SObject domain, and that class implements the fflib ISObject domain. Okay. If you're not familiar with what implementing an interface is or how that benefits you, let me just make it really, really, really simple. If you implement an interface, your class, or you extend something that implements an interface, your class can now be of that interface type. And the reason that your class can be of that interface type is because an interface forces you contractually to implement the methods in it. So if I implemented the fflib ISObject domain class, I have to, for my class to be able to compile and for me to save it, implement SObject type in the getRecords method. If I don't, I cannot implement this domain. I can't implement this interface. I won't be able to save the class and whatever else. So that's important because if I implement that class like this one does here, that means that I know I can run these methods, right? They have to be there. And more importantly, it means that I am definitively of this type, right? I can be declared as this interface type. So I know it's a lot of words, and this is really confusing if you're not familiar with object-oriented programming concepts. But what I'll say is, if you are confused about how this specific aspect works, go check out the GitHub articles that I wrote on this stuff, because it goes way more in depth, I guess, on some of these topics. And feel free to ask me questions too. I'm happy to answer them. So, all right. So we've got our new domain instance, right? And now we want to be able to determine whether or not that domain should create tasks. Okay, well, we're going to do the same thing here. We're going to say if the domain that we randomly generated here is an instance of the task creator interface, meaning more or less that it implements the task creator interface like this. And if it does, we want to call the create tasks method, right? So again, let me just show you task creator interface. Because I implemented this, I have to, absolutely have to, put this in the class that implements it. So let me just show you. If I delete this method here and tried to save this, well, haven't saved stuff in a while. Let's just ignore that everything in the whole world failed. And all right, so if we bring up the error log that I know you can't see over there right now, down here it says class cases must implement the fflib is object unit of work task creator interface create task method, or it can't be deployed. That's what that says down there. I know it's a little hard to read. Oh, okay, there we go. Cool. But that's what that says right down here, right? You've got to implement that method that we just deleted. Important stuff. Very critical in learning the benefits of interfaces. Okay, so now we've put our create task back into place. We come back over here, and if you take a look at this, right, if we know for sure that if the object domain also implements the task creator interface, we can call the create task method, because as we just saw, you have to implement that method, right? Absolutely must implement that create task method. If you don't, you can't be of type task creator interface. You can't save it. It won't work. Nothing's going to work out for you. So we're checking to see, okay, does this object domain that we randomly made implement the task creator interface? If it does, then we need to call the task creator create tasks method. And that's mostly it, right? Because of really two things: interfaces, which are magical. If you don't understand them, please take a little bit more time to go understand them, because you will benefit from them in a lot of ways, I promise, once you figure them out. Because of interfaces, which allow you to kind of declare less concrete types, right? Every single domain is of type. Every single domain I make, at least for the Apex Common library, is going to be of fflib is object domain type, because it's this class implements that interface. So it's easy for me to declare that here using that interface type. I grab my domain, check to see if my domain implements the task creator interface. If it does, call the create task method and get my job done. Pretty cool stuff, right? And again, this is all very dynamic. So, in the future, if I ever wanted to extend this to accounts like we were talking about, I would just create a new account domain class, have it extend fflib object domain, have it implement the task creator interface, and then implement this create task method, right? And have it do its own thing for that specific object type. So let's just real quick see how this works. I guess I didn't show you the abstract task creator controller. Basically, all it's going to end up doing is calling the create task method, and that's it, pretty much. So let's just figure that out. So we're going to call this. I'm not going to go over all of this, how this works yet. We'll cover this more in the service class method or video. But this task service.create task through the use of the factory pattern, basically just eventually calls this method. So let's go see. If I created a new task on cases, I want it to end up with a status of new. The subject should be origin plus subject. Who ID should be the contact ID. And the activity date should be today. So let's just check that out. I don't remember what I query for exactly. I think all open cases are new ones. So let's just hit the create task button. And you can see it did do that. Phone hi. So that's the case origin plus the whatever else I put in there. Case subject. And the contact ID looks like it put related contact stuff in there if there was something. So it looks like our task creation for the case object worked, right? And if we go actually back over here to our contacts, if we take a look at the contacts domain, wherever that is, we want the subject for the task status to be new, the subject to be contact name. So if we create the tasks, we can see the subject is the contact name, etc. Right? I think that my list that I built very quick is pulling in everything, including contact or case stuff that's assigned to me for the day. So, should have done a little better on the list, but anyway, the core stuff is there. Looks like we created those tasks appropriately and all that magical stuff. So, yeah, that is it. I know this is a very confusing topic, but as you can see, if you take the time to really sit down and understand the benefits of the factory method pattern, it can just drastically improve your code base, right? This is such a small amount of code that anywhere can call, right? Anywhere can call, and it will execute in different ways based on, what object is being passed to it. Whereas if I didn't do that, right, I have to declare all these if-else statements and all this gigantic branching logic. They could get pretty massive otherwise, right? So, factory method pattern, extremely beneficial in reducing code. Excellent at allowing you to have your code change dynamically during the course of its operation, right? So take the time to learn it. Hopefully this maybe helped a little bit. I know it's very confusing. It was not something that took me a short amount of time to comprehend, but hopefully this, kind of helps you figure out how to frame this in the context of Salesforce specifically, and then, what the benefits of using the factory method pattern are. Yeah. So if you're confused at all, I do have a GitHub wiki that goes over this stuff in a lot more detail. And, I have the same thing on my blog as well. Basically the same stuff, just, people who prefer to read a blog instead of a wiki. I don't know who they are. But just in case, I've got it in both places. So you can check out the description in the video to, I guess, read more about it. And Yeah, that's it. Hopefully this helped a little. I really hope anyway. In the next episode, we are going to go over the FFlib application class, which I know we went over a bit. In this one, we're going to go a lot more in depth on this class, the different methods in it, how it works, all that kind of stuff. So, yeah, hopefully that'll maybe clear more stuff up for you. We'll see. Anyway, thanks for watching, and I will see you in the next video.